Good morning, good afternoon, good evening. My name is Justin Raphael, and this is going to be my final discussion post for MIS605. So I'm going to go over the steps taken in the project. I'm going to go over the rationale behind the solution and the steps that must be taken in order to complete the information system development. So week one was a summary of the business process. So the summary of the deliverable was during the first week, the project involved conducting an in-depth analysis of the operational business processes with bike sharing systems, including bike renting, user management, and billing. The goal of that was to identify the key steps and interactions involved in each process to inform the development of an efficient and automated information system. Now, the rationale behind the proposed solution, the rationale behind this deliverable was to gain a comprehensive understanding of the existing processes within the bike sharing system and the challenges associated with them. By thoroughly examining each process, I aimed to identify opportunities for improvement and automation to enhance the user experience and system efficiency. Explanation of steps, so I had to complete the following steps. Conduct interviews with stakeholders to gather insights on existing business processes and pain points. Analyze the data collection to identify common patterns and bottlenecks within the processes. Develop a summary of the identified processes, including their descriptions and key attributes. Determine the scope and objectives of the information system to ensure alignment with business goals, and identify areas where automation and optimization could be applied to streamline the processes and enhance the overall system performance. Moving on to week two, the information system architecture and the components. So the summary of this was in week two, the focus was on proposing the information system architecture for the bike sharing system. A distributed model was chosen by me to connect the docking stations, manage user registrations, and handle billing efficiency. This deliverable also included a detailed listing of software, database, and hardware components involved with the information system. What was the rationale behind this? The choice of a distributed information system architecture was based on the need for a scalable and flexible system that could handle a large number of docking stations and users across a metropolitan area. By distributing processing power and data management, the system could handle increased demand and improved performance. The explanation of the steps that must be taken: conduct a thorough assessment of the business requirements and objectives to inform the choice of the IS architecture. Explore different architecture models such as centralized, distributed, and cloud-based, and determine the most suitable option for the bike sharing system. Evaluate the pros and cons of each architecture model, considering factors like scalability, performance, and cost. Chose the distributed architecture model based on its ability to support multiple docking stations and users across the metropolitan area, and created a detailed listing of software, database, and hardware components required for this proposed IS architecture. Moving on to week three, security risk summary. So during the third week, the focus was on identifying and summarizing the main security risks associated with this proposed bike sharing IS. This deliverable included an analysis of the potential consequences and recommended design strategies to minimize each risk. What was the rationale behind this? The security risk summary was a critical step to proactively address the potential vulnerabilities and threats of the IS, or to the IS. By understanding these risks, the development team could implement appropriate security measures to safeguard user data, protect against unauthorized access, and ensure system reliability. What steps did we take? Conducted a comprehensive security assessment on the proposed IS to identify potential threats and vulnerabilities. Analyzed the potential consequences of security breaches, including data breaches, server disruptions, and any financial losses. Explored various design strategies and best practices in information security to mitigate identified risk. I determined that the most suitable security measure for the bike sharing system, considering the factors like data encryption, secure authentication, and regular system updates. Developed a concise summary of the main security risk and the corresponding strategies to mitigate and minimize each risk. Moving on to week four, software component development. For the fourth week, the focus was designing and implementing a critical software component of the bike sharing system, the billing schema. A Python code was developed to handle the subscription checks and calculate the price for a single ride based on the subscription status, pickup time, and drop-off time. What was the rationale? The development of the billing schema was essentially to ensure accurate and efficient billing for the bike sharing users. By automating the price calculation based on subscription status and ride duration, the system can provide a seamless user experience and accurate billing information. The steps taken: analyze the bike sharing case description and pricing policy to determine the pricing rules for different subscription types and ride durations. Design the software component to handle subscription checks and calculate the ride prices based on the provided rules. Develop the Python code that efficiently implemented the subscription check and price calculation logic. Conducted an extensive testing of the Python code to ensure accurate results and error-free execution. And finally, documented the Python code and its functionality for the future reference and potential modifications. Moving on to week 5, the business data architecture. During the 5th week, the focus was on designing the data architectures required to support the registration and billing process of the bike sharing system. Variables, lists, and objects were created to accurately describe the registered users, their statuses, and other important parameters. The rationale behind this: the design of the business data architecture was critical for efficient data management and seamless execution of registration and billing processes. By defining appropriate data structures, the IS could store and retrieve user information accurately, establishing a smooth user interactions and billing operations. The steps needed to complete this: conduct an analysis of the registration and billing process to identify the key data elements required for each process, define the variables, lists, and objects that capture relevant user information, subscription statuses, and billing parameters, organize the data structure in a logical manner to facilitate easy access and manipulation, ensure data integrity and consistency by implementing appropriate data validation and error handling mechanisms, and finally documented the data structures and their relationships to provide clear documentation for future development and maintenance. Moving on to week 6, relational database structure. The 6th week will be involved designing a relational database structure to store data on current and historical rides in the bike sharing system. Tables were created to capture ride details, and SQL statements were written to compute average ride duration, check bike station occupancy, and retrieve a list of current active users. The rationale behind this: a relational database structure was chosen for its ability to effectively store and manage structured data. By creating separate tables for ride details and implementing SQL statements, the system could retrieve relevant ride information quickly and perform complex queries effectively. The steps needed: identify the data elements required to store the ride details, including the pickup time, drop-off time, ride duration, subscription status, and bike station occupancy. Created a relational database schema with separate tables for the ride details and user information. Developed the SQL statements to compute the average ride duration for a given user, check the number of bikes checked out at a specific bike station, and retrieve the list of active users. I tested the SQL statement to ensure its accuracy and efficiency in retrieving the required information, and finally I documented the database structure and SQL statements for future reference and maintenance. Moving on to week 7, the final week focused on creating a comprehensive development and implementation plan for the entire bike sharing information system. The plan outlined the system overview, system organization, security requirements, and major tasks associated for the successful IS implementation. The rationale: the development and implementation plan provided a roadmap for the successful execution of the IS project. It ensured that the aspects of the system development, deployment, and maintenance were systematically addressed, leading to a robust and efficient bike sharing system. The steps needed to complete this: conduct a thorough review of all previous project components to gather information and insights for the development and implementation plan, create a system overview highlighting core functionalities, user interactions, and overall business processes supported by the IS. Detailed the system organization, including software and hardware components, their roles and interactions. Summarize the security requirements and features necessary to protect user data and ensure system integrity. Prepared an annotated list of major tasks required for the system development, including system design, hardware deployment, data mitigation, user training, and system deployment. In conclusion, throughout this course project, we've taken significant steps towards designing and implementing a robust bike sharing information system. Starting with the analysis of business processes and architecture design, we focused on security considerations, software component development, and data modeling. The relational database structure was carefully designed to manage ride information efficiently. With the development and implementation plan in place, we are now well prepared to execute the project successfully, ensuring a seamless and user-friendly experience for bike sharing users. The course project has provided valuable insights into the complexities of IS development and offered practical solutions to address real-world challenges. That is my final presentation, and thank you for listening.